Hey everyone, welcome to week 4, day 2 starters. We have 2 questions today. Both have to do with scale factor, just like yesterday's. We are going to determine the scale factor of these 2 rectangles here. Now, yesterday we talked about similar figures and how similar figures have a scale factor that work between both of the corresponding sides. They should be the same if they're similar. If you were to find the scale factor here and they'd be different, they would be not similar figures. But in this situation, it says determine the scale factor of these similar figures, so it's already indicating that they are similar. So I'm going to go ahead and set this up in a proportion. I know there's not going to be a variable, but that's okay. So I'm going to do 2.5 inches over 3.5 inches, and I'm going to do 15 inches over 21 inches. And the reason I did that is I did short side over long side, short side over long side. You just have to have a system. If I were to flip both of these and still solve, I would still get the same answer. So to find the scale factor, I've got to find the multiplier that goes from one side to the other. So I need to figure out what times 2.5 gets me 15. So, I guess the best way to do this would be divide, unless, of course, you've got some other method, like I know 2.5 times 2 is 5, and then 5 times 3 would be 15, so I know 2 times 3 would be 6. So I think 6 is our scale factor. Well, let's go ahead and double check that with a calculator. I'm going to do 15 divided by 2.5. 15 divided by 2.5 is 6. So I'm going to multiply by 6. And down here we need to double check because they have to be the same if they're similar. 3.5 times 6 does get us 21. So times 6. So it says, what is our scale factor? You can write it as a ratio or you can write it as just 6. But I think the way it's formatted in Class Kick, it says the scale factor is 1, 2, and then so what would I multiply? Or using the scale factor of 6, 1 times 6 would be 6. So make sure you put that in to your Class Kick. Looking at number 2, it says rectangle A and B are similar figures where A is the original figure and B is the new figure. Find the new area of rectangle B. So we know that they're similar, so they should have the same scale factor. And we're going to do our scale factor from left to right because it says figure B is the new figure, so we will go left to right, which makes this a little, tricky. So I'm going to set this up via proportion, then I'm going to kind of walk you through how you didn't even need to do that. But before we do anything, you need to know that scale factors, like in number 1 in yesterday's, is always times. You're always multiplying by something. We don't consider division because when you divide, it's the same as multiplying by a fraction. So when we're looking at scale factors, you would say times 1/2, and that would mean divide by 2. We're going to do that here in number 2. So I'm going to do short side over long side on both. So that'd be 9 feet over 15 feet equals short side over long side x over 5 feet. Now, again, I told you I'll shorten this up a little bit here in just a second. But we can solve for x, and that's not going to be our answer, but that would get us close. We could use scale factor or we could cross multiply. I see a scale factor here. Now we're going from big to small, so our scale factor is going to be a fraction because that's the only way to multiply a number and get a smaller number is a number between 0 and 1. So 15 times what would get us 5? Well, I guess in our mind we need to ask ourselves 15 divided by what gets us 5? And that would be 3. So all you do for scale factor using fractions is put 1 over 3 because 15 times 1/3 would equal 5. So if I want to divide by 3, I just say times 1/3. And that's going to be how you do your scale factor. So again, if I do times 1/3 up here, because these are similar, they have to have the same scale factor on top and bottom, 9 times 1/3 would be 3 feet. So that's going to give me 3 feet here. But that's not what it's asking. It says find the area of the rectangle. So for area of rectangle, we need to do A equals length times width. And when you do that, it doesn't really matter which one you plug in for length and width, but I'm going to do 3 times 5, which should get us 15. And I don't think Classic makes you put the units, but it should be in feet squared. Hopefully that's enough for you all to go back and fix any kind of problems that you're struggling with in Classic. If you have any questions, just reach out with your hand and I'll swing by, and I or Miss Hutchinson or Miss Powell will swing by and help you out. All right, have a good rest of the day, and I hope to see you soon.